Now if we confine ourselves again to the plane y equals 0.69, okay, the y coordinate goes this way, so 0.69 is y equals 0.69 is going to give us a plane parallel to the xz plane, kind of this left face of this object that we've drawn here. Now I've completed the object, I've completed the front and the side because we simply need them for reasons that will become apparent. Okay. The z versus x graph in this plane, y being 0.69, is z equals x squared y, which is 0.69 x squared. So this is our function in this plane. And I've sketched a bit of the graph of that function. It's actually going to, this is a very small interval here. All the scales are messed up, so we're not going to get a good representation of the actual slope. But this line is going to have a positive slope. Now, it looks like it's going down. How do I say it's a positive slope? Well, this is the positive x direction, and in the positive x direction it's going up. So it's like a little segment of this parabola here, where x equals 0.71, which it does at this point, and y equals 0.35. And points in close proximity to this one. Okay, now in the yz plane, where x equals 0.71, x is confined to be 0.71, we get z equals x squared y, and x being 0.71, which is an approximation to the square root of 2 over 2. 0.71 squares out to something pretty close to 1/2, but that's a representation of square root of 2 over 2, so x squared is going to be 1/2 times y. And graph of that would look like this. Now, in the xz, in the plane parallel to the xz plane that goes through this point, the x coordinate is 0.71, the y coordinate is 0.35. Because of course, if we plug in 0.71, or the square root of 2 over 2 more accurately for x, we are going to get something close to 0.35. And here, the y coordinate is 0.69, and if we do x squared times y, well, x is 0.71 representing the square root of 2 over 2. The square is going to be 1/2. We're going to get 1/2 y. Half of this is about 0.35. So, either way, we get the same value, which is a good thing because these two curves meet at this point. Now, this curve has a positive slope. Y goes this way, so it's going to be rising as we move in this direction. And I'm just going to draw a representation of that. Okay, now again, the scales are not consistent, but I draw this like on top of this edge of the figure, okay, of the solid that I've drawn here. Okay, so we know that this has a slope that's equal to the slope of this function at this point. So this has a slope of 1/2 because the slope of z equals 1/2 y is always 1/2. So over here we have a slope of 1/2, and here we have a slope of what? Well, derivative of this is 0.69 times 2x squared, times 2x, I'm sorry, and 0.69 times 2 times 0.71 is equal to the slope we get here. Okay. If we work that out, put in square root of 2 over 2 here, you're going to get 1/2 times 2x, and the slope is going to be very close to this. Okay, so the slope here I'll use the numerical approximation, although might be better off using square root of 2 over 2. Okay, so this is a little steeper than this. Now, I want to make sure we understand how all this fits into our picture. What happened? We chose the point where t equals pi over 4. That gave us a value of x of t equals cosine t equal to square root of 2 over 2, which is about 0.71. So there's the x coordinate. Y of t, natural log of 1 plus 4 times pi over 4 divided by pi. Well, that comes out natural log of 2, which is very close to 0.69. There's this coordinate. We found that then if t changes by 0.02, this causes the x coordinate to change by an amount that's equal to the derivative of x with respect to t times that 0.02, which is negative 0.014. So that gives us our displacement 0.014, and y to change by plus 0.013. So there where all the numbers come from. It all starts with pi over 4 and the increment 0.02. If the increment was 0.01, then these sides would be half as long. Now the question then is, what's the net change in the value of the function? Well, all the information is right there. By how much does the function change from here to here if we assume that the slope above this segment doesn't differ much from this slope, and it won't because x is not changing by much, and the slope on this side doesn't differ much from the slope on this side. Think it out, we'll calculate it and see where everything falls together.